Ionic compounds can also form with polyatomic ions. Here is a list of common polyatomic ions. You could find a similar list online or in your text. I will supply you with a list as a reference, but eventually you will have to have them memorized. You do not get a list of polyatomic ions on the AP exam. Some of these ions are easy. The difficult ones contain oxygen. These ions are referred to as oxyanions. An atom could form anywhere from 1 to 4 different oxygen-containing ions. Take the oxyanions of sulfur and chlorine, for example. Sulfur forms 2 oxyanions, SO4 2- and SO3 2-. In this case, a different suffix is used to distinguish between the ions. The ion with the least amount of oxygens uses an ITE ending. The one with the most oxygens uses an ATE ending. So this is sulfite and this is sulfate ion. Now chlorine forms 4 oxyanions. So not only do the ITE and ATE suffixes get used, but different prefixes must also be used. The ion with the least amount of oxygens uses a hypo prefix and the ITE suffix. ClO- is hypochlorite ion. ClO2- only uses the ITE ending. It is chlorite ion. ClO3- utilizes only the ATE ending. It is known as chlorate ion. Finally, ClO4- makes use of the per prefix and the ate suffix. It is known as the perchlorate ion. So the most number of oxygens gets the prefix per, the least number of oxygens gets the prefix hypo. I wish there was an easy way to learn these ions, but repeated use is the only way. Heavy repetition, aka memorization, is their best strategy right now. Let's get it started. Follow the game plan. Ask yourself, is the first element a metal or a nonmetal? Let's look at our periodic table and find Na. Eureka! We found it. So we know that Na is on the left side of the table in group 1. Na is a metal. Now follow the metal path on the flow chart. Na was in group 1, so we are going to follow that path on our flow chart as well. Now we see that we are simply going to use the name of the metal. The first part of the name will be sodium. Continue to follow the flow chart to finish the name. The next question we have to ask ourselves is the anion a nonmetal or a polyatomic ion? SO4 is a polyatomic ion. So when we follow the path, we see that all we have to do is remember, or look it up for right now, the name of the polyatomic ion. SO4 2- is sulfate ion. The name of our compound is sodium sulfate. Pause the video and try B through K on your own. D and J will flow through the chart as you start the video, and the rest of the answers will be given to you. Let's do the formula for calcium carbonate. Follow the game plan. Is calcium a metal or nonmetal? Calcium is right here on the periodic table, so we know it is a metal. It is also a group 2 metal, so we can follow this path on our flow chart. All we need is the symbol of the metal, Ca. Now we have to remember what carbonate is. An ATE ending tells us that we are dealing with a polyatomic ion. If we look it up, we see carbonate is CO3 2-. So we have to use the charges on the ions to figure out the final formula of the compound. We already know that carbonate has a -2 charge. Calcium is in group 2, so we know it will have a +2 charge on its ion. Remember, you can cross the charges to help you determine the subscripts. So finally, we determine that the formula for our calcium carbonate is Ca2CO3 Correct? Wrong again. You must reduce the subscripts if they can be reduced. It only takes one carbonate ion with a charge of -2 to balance the +2 charge on the calcium ion. The correct formula is simply CaCO3.